Okay, what is the graph of each function rule? And this is an absolute value function. And these absolute value functions do a specific thing. They behave in a specific way. Um, and I'm going to just say, first I'm going to graph it, and then I'm going to show you uh, what the pattern is. Okay, so the first thing that we need to do, we need to say, since the absolute value of x, we need to take the absolute value of the x value, and then once we get that, we subtract 1. 4. Okay, so we've got negative 5 comma 4. And that is, I'm going to write it like this, but I'm not going to do the rest of them like this. That's essentially an ordered pair of negative 5 comma 4. We could plot it. I'll plot it in red, negative 5 comma 4 right there. Okay, and we keep doing that, and let's see what we get. Absolute value of negative 4. If we plug that in, it would be 4. 4 minus 1 is 3. Okay, doing the same thing all the way down. Absolute value of negative 3, 3. 3 minus 1, 2. Absolute value of negative 2, 2. 2 minus 1, 1. That's the resulting y value for that value of x. Okay. Negative 1. Absolute value of negative 1 is 1. 1 minus 1, 0. Absolute value of 0 is 0, and 0 minus 1 is negative 1. Watch what's going to happen now. Okay. Just like here, these both result in the same absolute value. Okay. So watch what happens then when I plug it in. Absolute value of 1, 1. And then that 1 minus 1, 0. And we get 0 again for this one, and we start to get a mirror image. Okay? Absolute value of 2 is the same as absolute value of negative 2. So what's the absolute value of 2? It's also 2, just like negative 2 was, right? So 2 minus 1, 1. Right? Absolute value of 3, 3. 3 minus 1, 2. Absolute value of 4 is 4. 4 minus 1 is 3. Absolute value of 5 is 5 minus 1 is 4. And so if we plot those points, and I'll plot them in red, we've got negative 4 comma 3, negative 3 comma 2, negative 2 comma 1, negative 1 comma 0, and 0 comma negative 1 is down here. And then it starts going back up. 1 comma 0, 2 comma 1, oops, 3 comma 2, 4 comma 3, and 5 comma 4. And those lines would extend for forever if we continued them from this vertex point, from this reflection point right here, okay, through all of those points. And I'm just going to adjust that down to there, and then do the same thing over on this side, like that. Okay. And that's the absolute value function that you get. What's going on there? Well, here's the big idea, and I'll start applying this later, so hopefully you watch this video, and I'll refer everybody back to this one to really see it, okay? This right here, since it's just as x inside, okay, whatever makes this 0, and since it's just x inside, 0 is going to make a 0 when you get the absolute value. Whatever value of x makes the inside here 0 is going to be where this line of reflection is. And in this case, 0 makes the inside 0. You'll see other examples where it's not that later. And so this is the line of reflection. And then that vertex point is going to land on that line. Where is it going to land on that line? Well, it's going to land on that line at whatever number this is, negative 1. That's the furthest down it's going to go, and it's going to do this in either direction from there. Okay, let's look at the next slide on this same video, and let's see what we get again. Okay, so how does this one change from the last one? Well, there's some difference, but a lot of things are the same. We still got this minus 1 at the end from problem 24, okay? And we don't have anything added or subtracted inside. We've just got a multiplier of 3. Right now it's x times 3. So when we plug it in there, we say, let's just do them, okay? Negative 5 times 3 is negative 15. That's what we've got inside when we substitute negative 5 for x. And now the absolute value of negative 15 is 15. 15 minus 1, 14. Okay? And just for a second, I'm going to jump down here to 5, all the way at the bottom. just to show you what's happening at 5. Well, if we multiply 3 times 5, we get 15. Absolute value of 15 is 15 minus 1 is 14. That also results in the same thing. Okay? If there was a plus or minus inside, that would change it. Okay? And we'll hopefully see that in another example later. Okay? So we're still going to get this mirror image around whatever line, whatever x value, like some vertical line, where the value that you put in for x makes this thing 0. And what number for x would make this 0? Well, 3 times what would give you 0? 3 times 0. So we're actually going to see, you will see the thing changing direction along this somewhere. And in fact, we'll find out that it's also the same place as the other one, -1, because of this. Okay? So anyway, let's do it. -4. -4 times 3, -12. Absolute value of that is 12. Minus 1 is 11. So this becomes 11. And again, same thing down here. 4 and -4 both result in an absolute value of 12. Minus 1 is 11. So I'm going to fill that in down here like that. Okay? Oh, and right here, I'm sorry, I made a mistake. You probably maybe caught this. Oops. Is that I typed actually accidentally -5 there again. I meant to put a 3. Sorry about that. So -3 times 3 is -9. Absolute value of -9 is 9. Minus 1 is 8. So we've got an 8 there. Okay, sorry for that interruption. I'm back. So anyway, also 3 times 3 is 9. Absolute value of 9 is 9. Minus 1 is 8. So this is also 8. And you can see that it's going down by 3 every time. And that's because of this 3 in here. Okay, so anyway, we're still just calculating. We'll just plug it in and calculate it. You don't have to worry about all those patterns. But plugging in -2 here, okay, -2 times 3 is -6. Absolute value of that is 6. 6 minus 1 is 5. And it's the same thing with 2 and -2. 5, okay? -1, if we plug it in, times 3 is -3. And absolute value of that's 3. 3 minus 1 is 2. And we'll get that same number for 1. Now 0 is where we get 0 on the inside, right? And that's going to be our lowest point. If we take the absolute value of 0, that's the whole idea. Whatever number makes this 0 means we're getting, for here, 0 for the absolute value. Anything else besides getting 0 for absolute value will give us a positive number, and that's always going to be higher. So the lowest we get is when the value of x inside makes it 0. And in this case, 0 makes it 0. So that's going to be our low point. So 3 times 0 is 0. Absolute value of 0 is 0. And 0 minus 1 is -1. Okay? So if we graph those points, you will see that for these points right here, we have y values that go above 10. And my graph that I've made right here doesn't go above 10. So what we're going to have to do is just graph the points that don't go off the graph. Okay? So we've got -3, 8. So we go over to -3 up to 8 right here. Okay? -2, 5 right there. -1, 2 right there. 0, -1. 1, 2. 2, 5. 3, 8. Okay? And if I was to draw the lines that I had put in there earlier, we've got a line going like that, and a line going like that. And that's what our absolute value graph looks like. How is that the same as the one we did just a moment ago? Well, the way that it's the same is we still have this, we still have the value of x that makes 0 inside is 0. There was nothing added or subtracted. So anytime you're going to get just a multiplier, what's going to make 0? A multiplier or anything times 0 will be 0, right? So as long as there's nothing plus or minus in there, you're going to get this line of reflection right here, the place where you get the vertex, that lowest point, and where it goes from a negative slope to a positive slope. This line right here will be at 0 if 0 for x makes 0 for the whole thing in there. Okay? And then how far down that line does it go? Well, that's this number. Okay? -1 means this is going to be 0. So the whole thing is going to produce 0 until you then say take away 1, and now that whole thing produces -1. We'll get some more practice on this later. The best idea for these is to make a table and plot the points and see where you get that lowest point. Okay? And then connect all of those points from that lowest point upwards through them like a V.